And
Good challenge.
okay, good. Great. What do I want to do? Cool. Okay, any questions about these? The first four? Great. Okay, so then let's just jump into the next one, popular names. Can someone summarize for me what popular names is asking you to do? Anyone? Popular names?
Asking us for the top 10 most popular.
Okay, great. You want to get me started?
Without looking at my
Yeah.
the select count star,
Okay, select count star.
and I'm gonna name that as this. Anything as what did I name? Name counter.
Okay. And what are we selecting?
We are selecting the. I'm sorry, I should start with that last name. Something, or it was actually both, right? It was first and last name.
Is it first and last name?
I don't remember.
Okay, big. Okay. Right, but we need to count for first and then last. So we have to start with one or the other. Cool. So we're selecting the first name because we want to count up the most popular first names of actors, right? Great.
So we're going to extract that information, that data from, I think it was the actors table.
Right. And so we have this aggregating function count, so we need something to aggregate on, some category, right? So we're trying to count up the first names, so we're going to group by first name.
Right.
Great. Cool. And we probably also want to order by this count. So we can say name count. We want it descending. And then we want to limit to the top 10. Does that look right? Okay, great. Can someone quickly explain to me how count is working with group by? It's like smushing all the marks together and then counting up the marks. And then doing the same for like the Stacy's or whatever, right? So each commonality groups it together and then it counts them. Make sense? Right. So let's see. I already have my, let's see if this works.
We got
the colon, yeah. No, syntax error. Count. Oh, I need a comma, right? See if that works. Okay, that looks probably like it's right. Yeah. Yeah, it would count any value. Yeah. Yes. We're grouping by first name, so it's counting up all the things, all the commonalities across that group. Yeah.
Group by also always has to go together with an aggregate function.
Yeah. To use group by without counting them?
Like I thought like they always have to go together.
Well, really I like to think of it as like count needs something to count. So it's more, to my mind, it makes more sense to say that count relies on the group by and not the other way around. Yeah.
I was just wondering if there's
another way to use movie line.
Yeah, what do you think would happen if I like got rid of this and just did this?
One minute counts not.
Right. So this is gonna like throw an error. But then what if I just got rid of this line?
It's just gonna give you alphabet like the first step. We're not.
Let's find out. Let's see if this works. Does anything.
Yeah, it is.
I think they're alphabetic.
Mhm. Right, so this is like a senseless display of data. That makes sense though, right? Okay, great. We're on the same page. I'll just... That's what I want to be doing. Man, this thing is really finicky. Right. First name. Right. Name count. Descending limit. Okay, cool. Everyone feel good about this? Great. So let's go on to prolific. Will someone please tell me what this one is doing? Yes, Andrew.
You want the list of the 100 actors that have the most credits.
100 actors that have the most credits. Okay. Yeah, most movie credits.
Yeah.
Cool. And we want to limit that to like 100?
Yeah,
Great. Do you want to get me started?
sure.
Great.
It's funny, my order is the opposite of what you did in the last one. I don't know what the difference is, but I had select count, paren as count on the actor ID. So I put the count first. Or I don't know, maybe I'm just not giving this away.
Okay.
Yeah.
Let's take a look at that later.
All right.
Right, prolific. So we need to get the first name and the last name of all the actors that actually have roles in actual movies, right? Cool. First name.
Actually, I think we just want their IDs. Oh, I'm sorry. Never mind. I take everything back. Just go ahead and do it.
Are you sure?
I did that nesting thing, so
Oh.
I had like 100 months IDs probably nested it in something else. So.
Okay, no worries.
Sorry.
No worries. Okay, so we know we need a count for this as well, right? And we can say that this is going to be like the number of roles, right? And so down here, we know we're going to group by or order by, at the very least, number roles. We can talk about what's happening with this in a bit. Because we want to order by the most prolific actors, right? So we're going to count them up and then display our data in that order. Jesus Christ. Here. Okay, this might come back. Great. Can everyone see this? Is it big enough? Okay, great. Great, and so in order to get the number of roles that were actually in movies, we need the actors, roles, and movies tables, right? And it's that roles table that connects the actors to the movies via roles. Does that make sense? Yeah, okay, great. So we know we need roles, actors, and movies. And then, of course, we can do this with a where or inner join. I'm going to do this with the where first. So from actors, roles, movies, where actors.id roles.actor ID. So give me all the actors who've actually had roles, right? And then roles.movie ID equals movies ID. So give me all the actors that have roles that are actually in movies, okay? Then we probably want to order by our unique field, actors ID, num roles by actor. Sorry, excuse me. I want to group by this. I'm ordering by the number. Group by actors ID, order by num roles ascending, and then I want to limit that to 100. Yeah, I think that looks right. Anyone have any questions about this?
You can draw from multiple tables at the same time.
Mm-hmm. Right, exactly. We can just list all of our tables on our from line, and then just where's our filtering clause. So then we establish, right, the conditions on which we actually want to aggregate this data by folding it in. We could do this with an inner join as well. Khadija. Oh, that's a good question. So theoretically, there could be actors or tables in our roles column, and if that don't actually map to movies. And I actually ran into this with another situation with genres, and we'll talk about that in a second. But if I look at my schema for, what is it, roles, I can see that this should provide me with has an actor ID, a movie ID, and a role. That role is a string, theoretically. And so this is like a join table, because this is how we connect actors to movies. But theoretically, there could be documents in this table that have an actor ID that matches that to a movie that is no longer existent. That like was maybe an IMDb page was created for that movie, but it was never actually produced. Maybe they deleted that field, but they didn't delete this corresponding document for that movie. That is certainly true for the genres table and the movies table, where there are genre documents that map a movie ID to a string like film noir, but that movie doesn't actually exist. And so in order to really protect the query from bad data, we're jumping over to the movies table and saying, okay, this role also has to connect to a movie that is in this table as well. But yeah, theoretically, if we knew that this data was like completely solid and consistent, then it might not make sense entirely to have to join in the movies table.
Couldn't the actors have multiple roles in one?
Sorry?
Couldn't one actor have multiple roles in one?
Absolutely. That's like a little less common, but yeah, certainly we have a query for that as well. So that's another condition that you're saying makes it.
That's why you join.
Okay, can you explain that and say that a little louder?
I think that's why you have to join with the movies. Or if I made a movie where I credited myself in 300 words,
Mm-hmm.
I immediately would jump to the top of this list.
Okay, cool. So
You probably only count as one.
Right. Okay, yeah, I think that makes sense. Right, so an actor might have many roles. By joining in with the movies table, we also protect against like an actor that we don't count the multiple roles. Is that what you're saying?
Yes.
Okay. But this will have a document for like 5 different, so say Ben Affleck is playing 5 different roles in, I don't know what movie Ben Affleck has been in, but you know, whatever movie. Then he'll have 5 documents in this table, right? And if I join with the movies table, as long as those roles were in actual movies that exist in the movies table, they'll still be counted, right?
Depends if you count the number of movies.
Oh, but yeah, okay, I hear
If
you.
you count the movies, then you would only account for one.
Okay,
actor per movie.
great, that is correct. So we would, to protect against multiple roles in a single movie, we would have to change the count to be operating on the movies, by movies and not by roles. Yeah, totally. But I just want to make it clear that just by joining with the movies, we aren't really handling the case where an actor has many roles in one movie, right? Because we're still counting roles then. So we'd still count each roles document as a discrete number, right? Cool. So, right, in order to make sure that only one movie is counted per actor, we would have to change the count. I don't think that's what this query is asking us to do exactly, but I like the idea to like make sure it's a little more rigorous in that way. Yeah, but have I run this yet? No, I haven't. Let's try it. Let's see if this works. Might take a while. Anyone do this with an inner join? Yeah, let's see what that looks like. Just make sure we're all feeling good about what the difference is. Great, so I'll get us started with that, and then we can complete it together. So we're selecting the first name, the last name. We're counting, same thing as num roles. And then let's start from the actors table. So now if I want to inner join, what should I join? Right, because that's my connector. And I'll just say on actors IDs roles.actor ID. And then I need to inner join what? Movies, right. On roles.movie ID, it's movies.id. Okay, and then what? Great. We can group by actors. We can order by num roles descending limit. Cool. Makes sense? Guess that's the same data. Let's see if this ran. Yeah, I think that's right. I remember Mel being at the top there. Cool. Yes.
I did it a little bit different. I didn't interjoin the movies. I just used the ID to list it. Is that correct?
Oh, you're saying you just like if I take out this line, that's your query.
Correct. Pretty much.
Yeah. And so you might just find, I think this is what I was trying to indicate earlier, you might just find that your number's a little higher because potentially there were documents created for actors that were going to act in movies that weren't actually created, or like, and in order to designate that, they might have then later deleted the document in the movies table for that movie, but they didn't also delete the roles document that indicates that movie. That makes sense? Yeah. Yes.
So in the select line, I instead of just using the first full name, I use actors first full name, and like I use the table for each one, so it doesn't matter really.
Yeah. Yeah, we don't need that here because, well, yeah. Does anyone have any idea of why we don't need to say actor's dot first name and actor's dot last name? Then, yeah, I think that's right. So it's because we're selecting clearly from this first table that we don't have to worry about a mix-up or throwing an error and saying, what table are you wanting to display here? Yeah. But I do like, I often do this as well because I think it's just like, makes it clear, right? These things are difficult enough. Let's not introduce unnecessary difficulty. Cool. Okay, so let's go on to the next one. Lowest genres, or bottom of the barrel, right? So what's this problem? Anyone? Sorry?
Define the genre with the least number of movies.
Okay, so least popular genres. Does that seem like a good way to do it? Okay, cool. Okay, so couple things about this one. I think it raises like a cool database design issue. Let me try to illustrate this. So we probably immediately know that we want to use the movies genres, or is it movie genres? Whatever, movies genres table, right? And that table houses documents that look like this, where it maps a movie ID to a genre that's a string, right? Cool. And theoretically, a document like this exists for every movie that's in this database, right? So theoretically, every movie has at least one document, but probably more because there are a number of movies that have many genres. Okay. Anyone see a problem with this, or like something that is making them scratch their heads, or like this is not ideal? Maybe any suggestions for how to fix it? Any thoughts? Yeah. Well, yeah. Say more about that.
Well, anybody can put anything in there. So I could put film noir without the bracket. And that would, you'd have to account for that.
Okay. Yeah. Yes. And what would you do to fix that?
Genres, table or object, ID to each genre.
Yes. Okay, cool. So I'll say that again. This is a string, and theoretically, we could a new document could be added that didn't have this dash, something could go wrong, and that's unreliable. And so a better way to do it would be to create a genre table that houses every genre document that we might associate a movie with. If there's validation, then, and there should be validation on this field, I shouldn't be able to create a document that doesn't map to a genre that is already pre-validated. So you can imagine I could have an array of strings, film noir, drama, action, and I could make sure before any document is created that the genre on that document is pointing to a string that is listed in my array of validated strings. So I'm not worried so much about validation here, but what's that? Yeah, and right. I think it makes sense for this to be a join table, I think, because what if I decide that, art is an evolving field? I don't know, it's not really a field, but art evolves. And so what if I decide it's like, 2016 and film noir post 2000 is actually like a really different thing. We still want to call it film noir, but people are doing cool experimental things. I really want to account for the distinction between pre-2000 film noir and like post-2000 film noir. And so what if I decide that like actually this is like film, I don't know. I want to make this post-2000 film noir. Or that's 200, but if I do that, then I have to then go into this table, find every movie made past 2000 or later, and then change this string in all of those places. And that's just a little silly. And if I had a document, so this is a movies MG document, right? And if I had a genres document, film noir ID is 1, and the genre or like name of this genre is film noir, right? And so if I had it this way, I could just reference the genre ID here and have that point to 1, right? And so if I want to change this later, I could instead create a new genres document for, post 2000 film noir FN. And then that way I would find all the documents in this table made past 2000 and just point that genres ID at this field, right? Or, I mean, and I think maybe the inefficiency of storing it in the way that it's currently stored will be even clearer if for some reason I decide that there's, I don't know, it's silly for a reason, it's causing problems for me to like have this dash here. Then I have to just go through and like remove that dash in every document that references film noir. But if instead I just had a genres document, right, that points to this, then I could just change that one document and every other reference to it would then be updated as a result of that. So if I ever want to change, or rather, okay, how's this? Date, if I had like metadata here, if I want to add some metadata about, you know, post 2000, and I want that to be reflected in the movie genres join table. Again, I just have to change this information in one place, and because these other documents are storing a reference to this one document, I don't have to change any other document. I just change it one place. Makes sense? Yes.
Would we still need the movie genres table? Or could we link directly from movie to genre?
Okay, so you're saying, what if we just, yeah, so now maybe we should just get this movies table and store a reference. Maybe this should be like an array since there are so many, a movie could have many genres, and this could have a reference to all the different genre IDs. Yeah, I think that's like a next logical step. I think this is probably the best way to handle movie genres. Especially in Mongo. Well, we can get into like why, I think it becomes clear why this might not be so intuitive, right, in SQL or in relational databases, right? Because when we store like many-to-many relations, this is how we represent this in relational databases. But I like your suggestion because this is how we would do this in a NoSQL database.
So SQL you couldn't join, you still do joins and stuff if the keys are in the array.
Yeah, we would actually, the way to do it would be to create a join table. And we already have an example of that. If we look at, that's exactly what this is, right? The roles table.
You would need a movie genres table like joins.
Yeah. Yeah, that many-to-many relation, or like one-to-many relation, rather. Right, and so in SQL, when we want to create relations like this and store references, we create a roles table, right? Have an actor ID and a movie ID and associate these two entities together. So that's why we're gonna have this movie genres table that looks like this. And then it could also store any metadata about that particular genre, right? It's like, I don't know, post 2000, experimental, I don't know, add any tags to really make plain what this genre is about and how it differs from like pre-2000 film noir. Just like our roles table, we have a string here that's adding additional information. We have actor ID and movie ID. But your suggestion really, yeah, brings home one of the differences between NoSQL and SQL databases. And if that distinction isn't immediately clear to you, it will be once we introduce you to NoSQL databases. But this is how we would store this in Mongo with an array that holds references right on the document, as opposed to creating this join table. Okay, that was like just my riff on why I don't like movie genres. I think it's, you know, a little silly to store a string there, but that is that. Let's actually get on to like constructing this query. So how should we do this? We need to find all the, right, count up least popular movies by genre, or find the least popular genres, right? So we can select genre. No, genres, movies, movie. So movie genres? Movie genres. Movies genres? Okay, cool. Movie genres. So that's probably the table I need, right? Yeah? You guys are really quiet. Okay. Count as num movies by genres. Actually, you know what? I need to this is my from movies genres. And then I can group by genre. And I need to order by, what's that?
When you first have your from change, so it's not movies.
Oh, thank you. Order by movies by genres. Cool. So here we are again, smushing all the documents with the same genre together and then counting them up. Did anyone, so that's one way to do it. Did anyone decide to use the movies table as well? Yes. Well, either one of you tell me why you did that.
I want to make sure it's a movie.
You want to make sure there was a movie. Great. Yeah, that makes a lot of sense to me. So we can like, this is what that would look like, I think. We can copy this. And what? We can interjoin movies on movies genres. That movie ID is movies.id. And order by genre, or sorry, group by genre, order by non-movies by genres. Is that what your query looked like?
Except I have ordered by movie.
Oh, yes. Cool. Yeah. So let's run this for a second and then kind of get into the difference. So let's see. Okay, great. Now, so this is our select where we're just using movie genres table. Let's see what happens if we throw this one in as well. Okay. You guys notice that the numbers in with the inner join with the movies table are lower? Any ideas about that?
Not all of them were actually movies.
Yeah, I would say that is correct. Means that we probably had some documents in the movies genres table that pointed to movies that don't actually exist. Okay, so we have some bad data. We need some data cleanup.
The solution when we were, like, walking through
Mhm.
was the option.
Right. Yeah. I think that's what it was doing. I think because technically you shouldn't need to do this validation, right? Since the movie genres table does provide us with these strings, film noir, and it has a document theoretically for every movie and mapping that movie to every genre that it falls under, you shouldn't need to then skip to interjoin movies. But yeah, it is a good validation, and perhaps we should change that. Perhaps that should be like, I think initially also we really wanted you guys to see that you only need the movie genres table technically and to question that database design. So I really wanted you to pause there and be like, why is it that this is storing these documents with genres that are just strings instead of objects with metadata associated with that genre? That's weird database design. Let me start thinking about how we design databases and that kind of thing. It's my other idea about that.
Well, I think if you're just looking at the table, I noticed that all the time with the strength of the genres table.
Yeah, yeah. So does anyone know the query that I would need to construct if I want to like definitely validate that there are some documents in the movie genres table that don't actually point to a real movie? Like asking you to construct SQL on the fly. Let me try to start coming up with that. I think I could just do, I know I need to, yeah. Yeah, I could do a left outer join, right? And I could do movies on, so I would do something like from movies genres, right? select the movie genres, left outer join the movies, right? And then I could say on movies genres, movie ID is movies.id. A little typo here. Cool. And then where movies.id, this is a trick question, you're not supposed to get this, is null. Someone describe to me what this is saying. Yes.
So you're trying to get
Yes.
genres that are not shared between movie genres table and movies ID, right? That aren't the same. So the idea is where it's null in movies. So like it exists in movie genres, but it's null.
Right. All the movie genres documents that have a movie ID field that points to a number that doesn't actually exist in the movies table. So pointing to a primary key of a movie where that primary key doesn't actually indicate a real movie in the movies table. So let's
do both line 79 and 81. Like I thought left outer join was using back. It's not shared.
you want to remove this one? Sorry.
Or 80, like 81 just gives you everything. Like if you got rid of that,
Yeah.
you're not filtering down or anything. Is that the problem?
Yeah, what do you think this will return us? Yeah, I think so, because we don't have a filtering clause.
So does it matter if you use left outer join or inner join on line 79?
Yeah, let's try a couple of these suggestions. Well, let's see what this returns. Not that this data is going to be particularly. Oh, cool. Well, okay, so that's not as. Let me do star. I want to get more information about this. Oh, keep doing that. Cool. So these are the movie genres table where these numbers don't seem to indicate actual movies. And I can try and validate that again. Select all, oops. Select all from movies where movies.id is this. Let's see. Great, nothing. Great. So now I've just verified that this one of these documents that has this ID actually, or rather this ID doesn't actually exist in the movies table. So here again, all of these documents, again, these are not primary keys of any movies. These don't exist. So there are documents that were created indicating movies that aren't actually in the movies table, which that was just a demonstration of why this query here will provide us with a more accurate accounting of the least popular genres than the above query that doesn't do the inner join with the movies table. I'll leave all of this here. We can sort of run through that later. I also want to, if we have time, play around with the left inner join, but I definitely want to make sure we get onto the harder problems. But yeah, so much experimentation here, and I think it's helpful if you guys feel like you want to play around with this later. Try to validate some of your queries, some of the data, and just like see what is, just play around. Make sure that what is returned is actually accurate, an accurate accounting of what's there. Cool. So what's the next one? I have a list somewhere. Braveheart. Okay, cool. And what's the problem there? Right, so we want to list the first and last names of all the actors who played in Braveheart, year 1995. Cool, so that's not, we can do that. So again, I think we want to move from the actors to the roles to the movies. When thinking about these like a little more complicated queries, I think it's helpful to chart out a roadmap. Say, okay, what tables do I need and how am I going to get from one table to the next? Actors, roles, movies is a clear bridge with given this database design. Cool. So we need the last name and the first name, last name. I don't think we're counting here, so we don't need a count. But I can just jump from actors to roles on actors.id, roles.actor.id, inner join movies on roles.movie.id, movies.id. Cool. And I need to make sure that it's the right Braveheart. Movies, where movies.name is Braveheart. And movies.year is 1980 something, 1990 something, 1995. And I want to order by last name, I think it says. Great. Any questions about this? Great. Let's do that. Okay, that should probably look familiar. I feel like Armstrong was definitely at the top there. Cool. Okay, you guys are feeling good about this one. Let's just continue. Let's see. Leap Noir. Is that what's next? Ooh, so yeah, this is a good one. So okay, what's the problem? What do we have to do? Join everything. Yeah, that's close. Right, but like what is it asking us to return? What data? For the leap years. Something to do with the film noir as well, right?
Yeah.
Okay. Great. List all the directors who directed a film noir movie in a leap year. That's the problem. We need a list. We need to get all the directors, find out the directors who directed a film noir movie, and then find if any of those film noir movies were made in a leap year. And we've obviously part of this is contrived because we're just going to do movies year modulo 4, which is equals 0, which is a little silly, but there it is. Great. And so what tables do we need? We need, okay, great. Movies, genres. We need the directors table. We need, there's a movies directors table. That could be helpful. Yeah. What else? Okay, movie genres, directors, movies. Yeah, I feel like those 4 tables should probably suffice. Yeah. Cool. Okay, so let's start. And we also we know we want to display the director's first name, director's last name, but the movie's name and movie's year. Cool. So how do you propose we get from one of these tables to the next and so on? Anyone see a clear line? Yes, Andrew.
We should either start at movie genres and start at directors.
Yeah, I think movies, directors, and movies is those 2 tables are connective tissue. So I think we can move from, either end. Why don't we start with directors? From directors, I think we can move to movies directors. From movies directors, we can move to movies. And then from movies, we can move to movie genres. Does that make sense? Okay, so just make it plain. B to MB to M to, MG. Cool. Great. So we'll select from directors. Inner join movies directors. 1, 2. Directors.id, movies directors. director ID. I think that's right. That's a director ID, right? Director's great. And then we want to interjoin the movies, and we want to do that on movies directors dot movie ID. Yeah, okay. It's movies dot ID, and then interjoin movie genres on movies dot movie. No, on movies genres dot movie ID is movies dot ID. Okay, can someone tell me what I have at this point? A lot of connect, but what are those? What's the meaning of these tables?
You figured out that the genres of all the movies that directors have been. That goes back to this.
Yeah. But that's like essentially the same, right? It's like all the directors who directed a movie, and a movie that has a listing in the movie genres table.
Yeah.
So I might have missed the table out. All the directors that have directed appear in a document in the movies directors table that also references a movie that's actually in the movies table that references a genre that's also in the genre table. All those things together. So this doesn't really mean that much at this point. But this is where we start filtering, right? So we can add a where statement to make this actually meaningful. We can say where the movie genres dot genre is film noir. So now we just have all the directors that have directed a film noir movie. Cool. And we need to make sure it's on the leap year. So we can say movies.year modulo 4 is 0. All the directors that have directed a film noir movie on a leap year. And then we can order by movies.name. Probably not.
You know,
I think we can probably get rid of this. Let's see. See if that works. Did anyone do this differently with like, whoa, that was fast. That's interesting. Okay. Does this look familiar to you guys? Any questions about this query? Yes.
I guess I'm just wondering, would it look nicer if we did it that way that you showed us, where you select from multiple tables? It was really like that syntax. It was one of the earlier problems where you would have from a million tables.
Yeah. So you're saying, what if we did, if we listed all of the tables here, movies, cool. Here, and instead of all this interjoining, we just did where and. Like, yeah, I mean, this is, trust me, the debate on whether one should use interjoins or wheres is like a hot one, and the relational database management system community. People discuss this all day. Some people are like, no, where's an and statement, so clear. I know exactly what's happening. Others like, no, interjoins are like way clearer. I hate anyone who uses wheres when we can be using interjoins. Really just a matter of temperament. But yeah, absolutely, we could definitely just where and our way to this result as well. It would look something like this, right? So, and this, and this, and that. That would probably get us the same thing. I might have a syntax issue, but let's try it. Was that slightly faster? Maybe. Yeah, these tables look exactly the same to me. Just a very quick scan. Cool. So And the real time is 0.189. Yeah, so this was a slightly faster query, the where and, given SQLite 3's daemon. User time 0.044. The user time was slightly higher, but the overall time, sys02. Yeah, the where and the and slightly faster, just very slightly. Well, great. So here we have these two options. This is where, this is our inner join. Cool. All right, so now I think we get to a really fun one. Bacon. Okay, can someone tell me, bacon was a new one, right? You had to do some new things. Maybe. Someone want to tell me about that approach? Any approach you took with the bacon that might have involved doing something you haven't done before up until this point? New terrain, uncharted territory. You're like doing this. Yeah, are you raising your hand? Oh, okay, do that. Okay.
Aliases.
Aliases. Why would we need aliases?
Because you're going to have to look at a few tables twice
Okay.
in different ways. Because you need to find movies with Kevin Bacon, but then you need to find the people who aren't Kevin Bacon. So you need to represent those twice under different names. I don't know if that's really.
Yeah, I think that's one of the clearest approaches. So we want to find all the actors that have acted with Kevin Bacon in his movies, his co-stars, all of the co-stars that exist for Kevin Bacon, right? And one of the easiest ways to do that is to use a copy of the actors table and the roles table to get Kevin Bacon's roles, and then use another copy to get all his co-stars, or like everyone else, and then say, but not Kevin Bacon. Does that make sense? Did anyone do this any differently? In a different tactic? Yes.
Did a nested search. Yeah, try to see intelligent table of just Kevin Bacon movies.
Mhm.
And after you match, do an outer join, or like inner join with that one as the inner one.
Mhm.
Where you join the roles and connect other movies that have actors who are in those.
Okay. And did you use two copies of the actors in the roles table?
Yes. Yeah, there's one side view for search for movies that have Bacon in them, the outer search for actors who are that were in the movies.
Yeah. Do we need two copies of the actors in roles table?
Is there a way to keep the actors table after filtering out the zone?
Yeah, this is I actually woke up in the middle of the night around this question. Seriously, I'm not joking. It was terrible. Yes, for some reason I was thinking about this particular query, and I was thinking about using different tables, and I was just like, man, I almost got up, had up, been so tired and frustrated, I probably would have gone on my computer and tried to like refactor my query to see if I could do it without two copies. It's not immediately intuitive to me that I should need them, right? It's like we have our actors table. When I alias it, I should be getting a pointer to it or a copy of a pointer so that I don't actually mutate the original actors table, right? And so that I could then reference it later and still know that it has all the actors. It doesn't quite make complete sense to me that I should need two copies. I should just need two different copies, pointers that are copies of it. That's like a slightly different thing, I think. I should have a way of referencing it that doesn't produce a duplicate. And I'm pretty sure that there's a way to do that. Like I'm confident there's ways to do that, but I didn't actually look that up. So this is the way we're going to do it. This is like the common way we're going to do it. But by no means do I feel prepared to say that this is the only way to do it. Yeah, and in fact, like I'm pretty sure, well, I'm not pretty sure, but I'm not sure this is the only way to do it. But we're going to do it this way. Man, we need to get a new rig. This is this one. Okay, cool. But as long as our approach is clear, let us proceed. Okay, so I know I gotta select a number of things. I'm probably, right, a bunch of names. But let's for now just come up with our tables and then alias them. Okay, and again, we could do this with inner join. I'm gonna do this with wheres and statements. So I'm just gonna list all my tables and their aliases on this one from line. Okay, so we have the actors table. I'm gonna call that one bacon because I'm gonna use one copy of this actors table to get bacon. I'm gonna get a roles table. I'm gonna call that R. Movies, I'm gonna call that M. I'm gonna get movie genres. I'm gonna call that MG. What else? I also know I need another copy of the roles table. Whoop. Right? I can call that one co-stars. Co-star roles. Be very clear. And actors I can call co-stars. Whoa, it's been long. Okay. Great. These exist over here. Cool. So I'm going to use these copies R and bacon to get bacon and his roles. And I'm going to use co-star roles and co-stars to get exactly what they seem to imply. Great. So I'm going to also get what I need to get the movie names, right? So I can actually reference this alias on the select line and say m.name. I want to get the co-star names, right? So I can say co-stars.first name. Oops. And here I definitely need to reference the tables. Okay. Co-stars.first name, co-stars last name. Cool. Is that clear at this point how I'm like aliasing and then referencing those aliases on my select line? Great. Cool. So now I've got this bacon table, which is just an actor table. I'm going to say where bacon first name is Kevin. So I'm looking for Kevin. And last name is bacon. And I need bacon here. Last name, bacon. Cool. And now I want to join with the roles table. Okay. So I want to find his roles, what he's actually played. Where bacon.id is r.actor.id, where he has find those documents in the roles table where he is referenced. And then I'm going to use this copy of the movies table to find those movies where he has played a role. Movie ID is, actually I'll start with r.movie ID is m.id. And am I missing a predicate? No. Oh, right. This is one of the conditions is that it's a drama movie, right? We want his co-stars for drama movies. That's why I need this, movie genres. Otherwise, I wouldn't need it. So where m.id is mg.movieid and mg.genre is drama. Okay, so cool. I've got my first part right here. This gives me Kevin Bacon's drama movie resume, basically, right? Got all the drama movies that he has been in. Cool. So now we have to go back and find all of the other people that played in these movies. Cool? Yes. Just trying to make sure you guys are with me. Okay, so now, good thing I have this second copy of the roles table. Because now I can do something like this. So that's the first part. Now I have to grab this movies. So I have these movies right now that have been whittled down to his drama movies. And now I'm going to use this whittled down movies table to find the co-stars. Co-star roles, using this alias for the roles table. Co-star roles, movie ID. Oops. Right. So now I'm finding all the roles associated with these movies. And co-star roles.actor ID, co-stars, and where those roles actually point to actors in the actors table. So now what do I have? Someone want to tell me the meaning of this query at this point? Yes, I have all the actors that have been in the movies, the drama movies that Kevin Bacon has been in, right? Including Kevin Bacon at this point. Oh, I don't know if it's my computer or not. Hmm. He will return. Do it. Okay. Okay, great. All the actors that have been in all of his drama movies, beautiful. So now we just have to exclude Bacon himself, and then we'll have the right people, right? Cool. So now, and co-stars.id is not Bacon.id, and I need that not. Boom. Order by co-stars.last name. Okay. So does anyone have another answer to the question I asked about whether I need aliases or copies, given what I have here? No? Anyone have any other questions about this? Mm-hmm.
When you list tables from, you kind of have like an implicit as, like this, display the second.
Yeah.
Could you put an as?
No, I don't think so.
Okay.
I'm pretty sure not. Right. Whereas with the inner join, if I want to alias, I need the as. Yeah. Yes. Hmm? I believe so, but I might be wrong about that. Did you use it without as? Okay. So we don't need the as in either case. I believe with SQLite 2, I needed it. I think, but I'm on SQLite 3, so maybe I've just poured it over syntax from 2 to 3. Have to double check with the API, yeah.
Right now, we might have the same actor more than once in the list. If one actor has to do different movies, that we make.
Mm-hmm.
Yeah, but we have to do it.
So we want to do it as well.
Do you want to say that again, or
So,
what?
it's just like, so if you just want the actors to wear movies, you probably could only get the actors.
Mm-hmm.
But we also want the movies, we need to have duplicates.
Right. We will have duplicates. But that's okay, given the constraints of the query. I think looking at this, another way to just think about what we're doing, the roles and actors table, is simply saying we have these two non-interlinked pointers to the same data, right? This in I think in like common JavaScript parlance would be called like a copy of a reference, as opposed to just a complete copy. Okay. Cool. So let's run this. Okay. was fast. And it's too long. Was I supposed to? What's that? Yeah, this is the movie name, and this is the actors. Oh yeah, order by, yes. M dot name. Yeah, he's a working actor for sure. That's a long career there. Not sure how he would. Okay, does that look familiar? Cool. I'm around 90% certain that this query requires this. That we need to have two distinct pointers to these tables. I am very confident of that. Cool. So now what's the next problem? Immortals. Okay, so great, this is a good one. Anyone want to tell me what the problem is? Actually, I'll tell you what the problem is, and then you guys can share with me your approaches. So we need to find actors that are listed in roles for movies made before 1900, and actors that have roles in movies made after 2000. You want to find the actors that were in both of those, actors that appear in both categories. So it's like, one approach would be find a table of actors and roles in movies before 900, create a table of actors and roles in movies after 2000, and then smush those together. Can people throw up ways that they achieve this? Huh? Okay, but what were some key words you used? That okay. Yes. And intersect. Great. Yeah, let's use intersect. This is a great place to learn about this keyword, and it does exactly what we want. And actually, if we think about it this way, this query becomes very simple, or no more difficult than any of the other queries, right? So yeah, let's do some joining. We'll say actors first name, actors last name, from actors, inner join roles on roles.movie, oops, dot on actors.id, roles, actor ID, inner join movies on roles, movie ID, movies.id. Cool. And then filter those down where movies that year less than 1900. Okay, cool. So now I have all the actors that have acted in movies that were created before 1900. Great. Cool. And wonderfully enough, I want to do the same thing for actors that were after 2000. There are movies after 2000. Great. Make sense so far? Cool. And now I just want to intersect those. Okay, so this should work. Do I want to order these by anything? I forget. It doesn't say so? Okay, cool. This should take a while. This intersect is not trivial. Yes. Another way of doing this might be faster. But I'm pretty sure that the bulk of this time is just because of this keyword here. Because think about what it's doing under the hood. It's like scanning that first table, scanning the last table, and like throwing in any copies. But how many table scans do you think that it has to do? Or like, what if you had to say these were two arrays with documents? the documents in these arrays have name fields. How would you write a program to see if, to find the intersection between those two arrays? I'll have to go on this. Yeah.
I guess I would like to take the first value from the first array and scan down to like the second array, and then put it in, go to the second value. And I'm gonna throw out a word that's
Yeah, I would say that's nested for loops. You would use nested for loops, one for loop for each array. You have these two arrays. So this guy has to create these tables in the first place. He's folding in, folding in, folding in. Gets a table of all the actors and movies before 1900. Does the same thing after 2000. And then basically with nested for loops, if we think of these as arrays with string names, you just move over it. Stop on the first one, check all the other ones. Check. Check. Oh, I'm missing.
What's cheaper, doing this or just doing alternate runs?
I don't know, let's try it. Let's see. Do you have a multiple inner join?
Yeah.
Do you want to Slack it to me? We can run it. Right? So this took, wow, yeah, 52 seconds, almost a minute. Okay, so let's put about 40 seconds. So we're talking about like a 12-second difference. It makes sense to me that inner join would be faster. Because if you think about it, it's not, well, I'm guessing you did a not equals, or what's the primary exclusion principle or inclusion principle for the joining of your inner joins? So it's like that where, and you're using, you're accomplishing the intersect with a where and clause at the bottom. Cool. Which, to my mind, it doesn't have to do that nested table scan for that. You can imagine that this doesn't create an exponential operation insofar as it's still handling these two tables and finding intersection. Right. Yeah, because that way it just has to scan, and if that year, it's scanning once for years. It gets this table where there are years before and after, and then just scans if it's greater or less. So it can be accomplished with one table scan as opposed to two, or like multiple rather. Many for each one. Make sense? Great, awesome. Okay, I think we're on the last one, is that right? What's that? Two more, okay, great. Busy filming and female actors only. Okay, I want to give you guys some minutes before you have to sit through SQL. Maybe we can do this really quickly. Busy filming. So what is a busy filming question? Busy filming. Great. Actors with more than 5 roles in any given movie, right? So we need to find, great. So our roles table is going to be critical here. First name, actors, last name, movies, name. Cool. We know we're going to count something. We'll leave that there because we probably don't know yet. But we'll call this, we know we're counting by roles. Cool. So now we need to find all the actors that had roles in movies. There is a where clause here, right? It's like movies after some date. 1990. Okay, good. Cool. Roles. So you did this with a where clause? Okay. We can do it either way. Okay, so now I'm getting all the roles for actors, and then I get all the movies. Got 2 ons here. And I want to find only movies where the year is greater than 1990. So all the actors that have acted in movies produced after 1990, and then I want to do what? But what I'm looking for are actors that have had more than 5 roles in any given movie made after 1990, right? So if, Leonardo DiCaprio played like 5 roles in the Titanic, then I need to count those up. So basically what I need to do is group this table by 2 different fields where 2 things are the same at the same time, right? This is why my roles table is critical here. Because if I group by actor and by movie, I'm getting a situation where the actor is in the same movie. And then I can count by that smushing to see how many documents there are for any given actor for the same movie. And that's because of this roles table here, right? Schema roles. This is critical. This schema design here. We wouldn't be able to do it without it. We have a table full of documents that maps actors to movies. So these 2 fields point to the same thing, Leonardo DiCaprio, Titanic, and there are 5 of them. There are 5 of them because the role is different across the 5. Doesn't have to be, but like that's like the point of the table. So hopefully the data is good enough to like handle that. Yeah, right. So we can add additional validation. I would claim that this validation shouldn't be necessary because in order to create a document in this table in the first place, it should have this validation called unique on it. And so if there's any other document with the same actor ID and the same movie ID, this should have to be distinct for a new document to be created. So there are ways in which we can set validation so that documents can't be created unless they meet certain criteria. But we'll just go ahead and protect our query against the possibility of bad data by adding the distinct keyword to it. Because we found, I was working with a group yesterday and we found that this is not the case. You will receive way more results if you don't add distinct. So you're preempting that problem. No, this is good. Okay, great. So that's just to explain the group by. We need a group by roles.actor ID and roles.movie ID. Okay. Cool. And so now what do I want to count by? I want to count by the role in this field. In particular, we'll add this distinct keyword, distinct roles.role. What's up? I think you can put it on one of these. I think it has to be on. Look at this line like this. It has to be on this line. Yes. Wait, not there. There. No. Yes. Okay. Cool. Get rid of that. Okay. Cool. And then we want to find those with more than 5. So, cool. Did anyone try to set this condition with a where?
Yes.
Cool. They call this normals. And did that work? Why didn't it work? Right. So the difference between having and where both filter, but having is the kind of filtering you can do post aggregation. And so we want to smush these together and then count them. We don't want to count them before we've smushed. And so that's why we use the having, because we aggregate and then we filter that aggregation to find only those that satisfy this condition of being more than 5. That's the only difference between having and where. It's about where the filtering is done, before aggregation or after. So this should work. And we'll take up the distinct and see the difference after. This should also take some time, but so it's like greater than, so it's like greater than 4 actually. Okay. Return to me. I'm sorry about this, folks. I think we need to get a new board. I'm almost confident at this point that it is not my computer. Okay, cool. Wow, it's still, okay, cool. Right, so this is gonna, I remember, yeah, did anyone else notice that this like really trickled in for you? Kind of gives you some interesting insight into how it's handling the having clause. I think this trickling effect is a function of having because this hasn't happened for any other query. Just sort of presented that table. There must be some sort of, I don't know, compiling condition for the having where it's like, if there's a having, well, just display the results as you get them. Cool, wow, yeah, that's 62 seconds. That's more than a minute. Great. I will take out the distinct and run that while we move on to the next one. We'll see. We do a compare contrast situation. Oh no. Oh. Anyways, there might have been more. I think there was more than this, but as Pat pointed out, this should be greater than 4, not greater than 5. But you guys get the idea. Okay, cool. Busy filming, done. Now, okay, last few minutes. Female actors only. Approaches, ideas. You tell me. Yeah, what is it asking for?
I want to know how many movies every year where there's only female actors.
Right. And that's there's the other way of saying that is give me the movies with no men in them. Okay, so what table has gender? Yeah, that table. So we're definitely need that one. And that's how we're going to do our filtering is with actors.gender. I'm guessing it's like that field, right, that exists that allows us to filter based on that. Cool. So there are a number of ways you can approach this. One of the ways you could do it is to get all the movies with men in them and then say, find another set of movies where these do not exist. So again, like kind of like finding the non-intersection. Okay, some of you guys throw out some approaches you took. I'm guessing there were some sub-select clauses going on, maybe. Anyone think they did anything cool, interesting with this one? New keywords in particular, yeah. Case.
Yeah, so it's like it's a house.
Mm-hmm. Mm-hmm.
It's least when else. Oh, when I male, then we have 1 else and 0.
Okay, cool. I like that. Sweet, will you slide that to me? I'll throw it up here so that folks can see it. The case clause. Okay, the way I went about this was I found all the movies with men in them and then found movies that did not include those movies. Oh yeah, let's try that. So we can select all. Let's see. Well, actually, a number of ways I could start. So starting with movies, and I don't have to start here, I can start with actors, but let's just do that. Implement roles, not roles. On movies. Cool. Nothing new here. And then actors, which is capital N. All the movies with male actors is what I have right now, right? And I think there is another We want to group by year. Is that correct? Cool. So we can see the change over time, if there is any change over time. So at the end of my query, I know I'm going to be grouping by movie year, the year in which that movie was made. Cool. And now, so this is going to be something of a inner clause. And I also, I'm selecting the year. I think I'm counting all of them. I can call this female only, maybe. And then I think to have all my movies. Yeah. I call this, should I call it something different? I'll say from movies M, and that way I don't need this. I can say M. This is getting confusing. I'm going to do this a different way. I'm going to get this again. Select all. So from movies M, I have my alias here. I'm going to say from roles. Okay, that's from roles R after it's A. Oh, here, A.ID. M.ID. Cool. Cool. Great. Some wheres. There we go. So great. Cool. Okay. Yes. This is a good way to do it, because definitely I just have this one table M from movies M where these folks don't exist. These great. Actors, gender. Cool. Any questions about any of this? Anyone want to tell me I have a syntax issue? Ooh, yes. So I need this to be an and. Right, am I allowed to have only one where? Yeah, per subquery, right? Per grouping operator. This is how I designate subquery, these grouping operators. So now I can say where movies where this doesn't exist. Group by year. Cool, try it. Wow, was I running? Right, so this was 35 seconds. This is, I removed the distinct. I think that's the only distinction. Pun intended. Cool. Okay, so it's significantly faster. Wait, which makes sense, distinct. That's like a major validation to have to perform. Huge. Impressive, that nearly doubled the time. Okay, great, so here we go. And year for movies will not exist. Man, who knows how long this will take. Woo! Let's see. What? Is this right? Can anyone tell me if this looks like the expected result set?
Yeah.
These numbers look weird. I don't trust them. Does anyone think these numbers make sense? Not at all, right? Yeah. Yeah. It is a random subset of data. It is real data, though. This is like, we didn't fabricate this. We stole it. What?
Yeah.
We just took it. Yeah, I think Zebra's responsible for this. I don't know if you guys can see But-
Well, you saw me some.
Oh, yeah. Oh, yeah, you want to see the query? Great.
This is all gonna be in.
I'm going to upload it to your solutions library. Yes. Yes. Yeah, and I'll leave the alternatives here. I want you guys to get comfortable with this idea that there are many ways that you can get to the same result set. So as long as you're comfortable with one of those ways, you might be more comfortable with wheres and ands, might be more comfortable with inner joins. Doesn't matter. You can get there. Moving into another approach will be easier down the line. Cool. Any other questions? We got to wrap up. Questions, concerns? You guys like really feeling SQL now? You guys are pretty. I mean, I hope you feel empowered. These are not easy queries to construct. It's not as if like, you know, database admins are constructing these all the time in their sleep. You know, I think these even a professional has to think about these a little bit. You know, obviously they're better than you and I, but you know, these are not just simple. No one's expecting you to like throw them out there without any planning or any road mapping like we've been doing together. So feel good. Not easy at all, and you guys have not like got to a significant level of mastery in a very short period of time. So I applaud you. Okay, great. Please take a couple minutes of break. Omri will need that time to set up anyways. Get some water and stretch, and we'll start with SQL.